Alright, today we are talking about simplifying radicals. Now what is a radical? That is a square root or a cube root. And you can tell the difference because your square root doesn't have anything right here on that radical. This one has a little 3 on that radical. So what's the difference between both of those? If you have a square root of, say, 25, then you're looking for what number squared makes 25, and the answer would be 5, because 5 squared is 25. But a cube root, you're looking for what cubed would make it. So if I said the cube root of 8, what times what times what makes 8, you would say 2, because 2 times 2 is 4, times another 2 is 8. Now for all our radicals today, so again, a radical is a square or a cube root, they're not going to be what we call perfect cubes, like 8, or perfect squares, like 25. Here are all my other perfect squares right here. These numbers are going to be more like the square root of 75. And if you took your calculator and you plug that in, so here I am, I've got the second x squared key, that's my root. I can get that out of the way for you. I put in 75. I don't have an answer to that, not a whole number answer. In fact, this is an irrational number, meaning this decimal goes on forever without repeating. It's a lot like pi. So I don't have just an answer I can give for that, so what I do instead is I simplify it. So here's how you simplify it. The first thing you should do is make a factor tree. We're going to find all of our primes. So what times what makes 75? I'm thinking 3/4 makes 75, so 3 times 25. 3 is prime, 25 is not. So the next thing I'm going to do is say what times what makes 25? That's 5 times 5. Now this is more of a sorting game than anything else. You've got your root. Inside, we're going to put anything that does not have a pair. On the outside, we're going to put any pair of numbers that we have. For example, let me switch colors. I have a pair of 5s right here, so I'm going to put a 5 outside. I have this lonely old 3 here, doesn't have a partner. He has to stay inside. So our final answer is 5√3. So why is this working? Well, it really has to come back to what we wrote right here. We wrote that 75 is the root of 25 times the root of 3. We knew what the root of 25 was. It was 5. We didn't know what the root of 3 was, so we just left it up there. So what we're really doing is we're just like simplifying a fraction. We're just doing it with a radical instead of a fraction. So let's try it again. First step, go ahead and write your factor tree. What times what is 80? I'm going to say 8 and 10. Though maybe you didn't start that way. Maybe you were thinking 2 and 40. That's okay. When we get this down to all of our primes, these things in circles, we're going to all have the same numbers when we're done anyway. So when I go to 8, I'm thinking 4 and 2, and 2 and 2. Now I've got 10 over here, which is 5 times 2. So I've got all my primes. Really, none of these numbers exist anymore, so don't really look at those. Those are composite numbers. If I want to know what 80 is, we're going to write it as 2 times 2 times 2 times 2 times 5. I want to show that to you again. What I'm talking about here. 2 times 2 times 2 times 2 times 5. And if we got all of our primes correct, then we should have the same number we started with. So we still have 80, we're just writing it a different way. So we're back to our sorting game. We're going to write our radical. Again, that's our square root. Radical, root, same thing. And if it has a pair like these 2's, it gets to go on the outside. That's like taking the square root of 4 right here. It is 2. We've got another pair of 2's right here. They don't have to be side by side. So another pair of 2's goes on the outside. This is where step 6 goes. We're going to multiply and eat primes next to each other together. And then we've got this one lonely little 5 here that doesn't have a partner, so he has to stay inside. So 2 times 2 is 4, root of 5, and we have our final answer right there. That is a simplified radical. Right. So these were square roots up here. Now I'm going to do 2 cube roots, and you can tell the difference because our square roots do not have anything right next to the radical, but our cube roots have a 3, and that's telling us that we need 3 of a kind. So a square root you need 2 of a kind, cube root you need 3 of a kind. So I'm going to start off with what times what is 72. I'm thinking 9 and 8. So 9 times 8 is not prime, so we got to do 3 and 3 for 9, and 4 and 2 for 8. And then another 2 2's right out of 4. So I've got all my primes. Again, none of these exists really. These numbers just helped us get to our final primes down here. And what we need to write is outside the radical, this time a cube root, so get that little 3 up there. It's not an exponent or anything, it's just a little script on our root. We're going to find 3 of a kind, put it on the outside. Anything left over goes on the inside. So if I have 3 2's, like those right there, a 2 gets to go on the outside. That's the same as taking the cube root of 8, which we talked about earlier, is 2. Now I have 2 things left on the inside. Like if this was a square root, it would have been fine to have 2 of them, but because it's a cube root, we actually need 3 of them, so those are both left over. So I've got a 2 on the outside, a cube root, and then 3 times 3 go back together as 9. Now, make sure that this little cube always stays on your radical. Make sure that this outside number here is your coefficient. Make sure that's a big. Don't try to put it up there as a little number next to the 3. It's a big coefficient. It's multiplied with that root, really, in between. If you need to write that symbol, go ahead and feel free to do so. Alright, next one we're going to do is the cube root of 32. So again, I'm looking for 3 of a kind. So I got 8 and 4, that's where I'm thinking first, which is 4 and 2, and 2 and 2. Almost done. I've got a tree over here I haven't finished, 2 and 2. Alright, so I have 1, 2, 3, 4, 5 2's. Let's see how this works out. So for my cube root, if it has 3 of a kind, I get to put it outside. So I'm going to pick these 3. You don't have to pick those 3. But we've got a 2 outside and 2 2's left over. So I'm going to put that back together. So that's 2. Cube root, 2 times 2 is 4. So 2 cube root 4. Alright, next 2 examples are going to add some coefficients that are already sitting there. So these are almost the same right here, except look at these outside numbers already. So whatever we find as a pair here is going to be joined with that 5. It's already there. Same thing here. For this cube root, whatever we find to pull out of this cube root as a triple is going to be multiplied again with that 3. So let's start with the square root of 200. I'm thinking 2 and 100, and then I'm thinking 10 and 10, and 5 and 2, and 5 and 2. So on the outside of my radical, I've got a 5, and it's going to be joined with another 2. Here it is, 2 and 2, so a 2 joins that 5. And look, I've also got a pair of 5's right here. So I've used up nearly all my numbers. One more left, this 2 right here. So this lonely old 2 goes inside. So we just got to put this back together. 5 times 2 is 10. 10 times 5 is 50. So just put that together, and then the square root of 2. Remember, I was looking for pairs because it didn't have a little number here, so I knew it was a square root. So you're looking for pairs. Alright, now on 59. Sorry, 54. What times what is 54? I'm thinking 9 and 6 to start with. 9 is 3 and 3, and 6 is 3 and 2. So, do I have any 3 of a kinds? And yes, I do, right here, 3 3's. So those 3 3's are going to be joined by the 3 outside. And then, I've got this 2 that's left over inside. So put my 3's back together. 3 times 3 is 9. Cube root of 2, all done.